geometric progression. In our previous class, we talked about arithmetic progression. Today we'll be talking about geometric progression. So geometric progression, first of all, how do we know whether a substance is a progression is geometric or arithmetic? In the previous class, we were told how to detect whether something is an arithmetic progression or is an arithmetic progression. So today we are going to tell you how you will know that this is a geometric progression before you solve it geometrically or arithmetically. So now, in geometric progression, for a compound to be a progression to be geometric, it must obey this rule: y is equals to square root of x z. For example, if you are given a progression as 1, 2, 3, 4, 5, and you are given 2, 4, 8, 16, and you are asked to check whether the following is an arithmetic progression or a geometric progression. For an arithmetic progression, we say y is equal to x plus z divided by 2. So let's check for the first one. It will be 1. This is x, y, and z. This is x, y, and z. So for the first one, x is 1 plus z is 3 divided by 2, which is equals to 4 divided by 2, which is equals to what? 2. So check our y. Our y is 2. So in this case, we say it is an arithmetic progression. So this one is an arithmetic progression. So let's check the second one. Y is equals to 2 plus, what is our z? 8 divided by 2, which is equals to 10 divided by 2, which is equals to 5. So y is not 5. So this is not an arithmetic progression because y here is 4, meanwhile here we got 5. So now you check whether it is a geometric progression. We say y is equals to square root of what is our x? 2 times what is our z? 8, which is equals to square root of 2 times 8, 16, which is equals to what? 4. So in this case, y is 4, therefore this one is a what? Geometric progression. Another thing is that in our arithmetic progression, we deal with common difference. But in terms of geometric progression, we deal with common ratio. So now, in getting common difference, we use first term minus second term. Like here, our second term minus first term. Like here, this is our second term 2, and our first term is what? 1. So to get our common difference, we say 2 minus 1. But in terms of geometric progression, to get the common ratio, we say it will be equals to what? The second term divided by the first term, which is 4 divided by 2, which is equal to what? 2. So meaning, to get each of this term, we have to be multiplying by 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. What also the common difference is saying is 2 minus 1, we have equals to 1, meaning you have to be adding 1. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4, and so on and so forth. So now we are going to move straight into actions in geometric progression.
Now, let's start with introduction of the formulas. GP, which is our geometric progression. To find an n term in the GP, you know, in AP, we were talking about first term, number of term, common difference. But in GP now, we'll be talking about the first term and R common ratio as formation by one of our tutors. So common ratio now is as common difference in an AP, but in a GP now we lay concentration on ratio because we are dealing with division and division. Yeah. So now to find an n term in a GP, you illustrate the formula as Tn is equals to Arn minus 1. This is the formula to find any term in a GP. The first number is the first term. The first term. R is a common ratio, and N is the number of term. Number of term. If you are given any problem to solve or any question, any word problem question that you should look for an aid for a GP of any kind, just apply this formula. Once it is telling you to look for the first term or the common ratio or the number of terms, this is the formula you are to apply. Secondly, we have sum of an AP, sum of a GP, right? Xn is equals to what? We have two types of sum of an AP. When R is less than 1, we have its own formula, comma. Then we have when R is greater than 1, we have its own formula. Now, the first formula is when R is less than 1. When R is less than 1, the formula is Sn equals to 1 minus R raised to the power of n. There's an A here, over 1 minus R. This is the first formula when R is less than 1. If the R is less than 1, you subtract 1 from the R. Then secondly, when we have 1 greater than R, you have it as what? Sn equals to A open bracket Rn minus 1 over R minus 1. These are two formulas you use to solve for the sum of an GP of any kind. This first one is to look for the first term, the common ratio of the number of terms. Then this second formula is to look for the sum of any term in the GP, in the geometric progression. So we'll be looking at examples. Let's take example 1. So now, the first question is just very simple. Find the common ratio in the GP. Look at this. You're already told that it's a GP. You just move and solve. So find the common ratio for any GP. You know the formula, right? Tn is equals to what? A. Now, find the common ratio in the GP. 2, 4, 8, 16. You've already been told it's a GP. To find common ratio in the GP, as I told you earlier, it's just, ratio means what? Ratio means division, right? It's just to divide the second term by the first term, or we divide the first term by the third term. The second term here is what? The second term is 4. 4 divided by the first term. The first term is what? 2. Or what? The first term is 16. 16 divided by the third term, which is 8. 4 divided by 2 is 2. And 16 divided by 8 is what? 2 also. So, therefore, the common ratio now is equals to 2. It's either you use this first approach or you use this second approach. This is for common ratio. As very simple. Let's look into another example. Now, this is example 2. Example 2 says to find the sixth term of the GP. 3, 6, 12, 24. To find the sixth term, you know, we discussed earlier from the derivation of our formulas that to find any term in the GP, Tn is equals to what? A R raised to the power of n minus 1. If you check this formula, right, your data is what? You are given the first term, A equals to 3. You're given a common ratio. How do you get your common ratio? R is equals to T2 minus T1, which is equals to what? Oh, sorry. Your common ratio is what? We are talking of ratio, not difference. T2 divided by T1, right? Which is equal to what? Your T2 is 3, is 6. Your T1 is 3. 6 divided by 3, which is equals to 2. So therefore, common ratio here is what? 2. This is the only information you need. Then you apply it to the formula. Tn is equals to what? The first term is 3. Our common ratio is 2. Open bracket n. The sixth term, n is equals to what? N is 6. The sixth term, which is n, 6 minus 1. Now, 3 raised to the power of 2. 6 minus 1 is 5. 2 to the power of 5 is what? So, the first term is 3. Your common ratio is 2. Now, n is what? 6. Then, you put it here. 6 minus 1, which is 5. 2 to the power of 5. 3 into 2 to the power of 5 is what? 32, right? So 3 times 32 is what? 96. This is your sixth term of this GP. So thank you for your time. We'll see you in our next class. Thank you very much.